Hey guys, this is Mr. Sal. This is the Linearity Practice Test Review. I hope it helps you guys out. Jack is filling his empty swimming pool with water. The pool is being filled at a constant rate of 4 gallons per minute. Write an equation for the number of gallons that will be in the pool after m minutes. Alright, on this one, what we'll want on this is the slope and also the y-intercept. So, this will be in the form y equals the slope times the x plus whatever the y-intercept is. So there's two ways we can find the slope. Is we could look at the change in this graph, which is rise over run, up 2, to the right. Actually that's up 4, not 2. Up 4, and then to the right, 1. Now it went up 2 lines, but each line represents 2, so it actually went up 4. That would be a rise over run of 4, which is the slope. So that is the coefficient of x. Next up, we see that this crosses the y-axis at the origin, and that's also shown in the table here at 0, 0. So we can put plus 0 if we want. Some of you guys would just write y equals 4x, and that's good too. By the way, we've done this one already in class, so hopefully it looked kind of familiar. Based on the values in the table, find the slope and y-intercept to write the equation of the line in the form y equals mx plus b, which was the last lesson in the unit for this one. So, let's first find the slope in this table. So we need to choose 2 points. For the slope, I'm going to choose just the top 2 up here. So we need to remember that the y tells us the rise, and the x values tell us the run. This will give us the slope. So the rise, this is going from 12 up to 20. So that would be up 8 units, which gives us a rise of positive 8. That's good so far. And then the run, this is going to the right from 3 to 5. But how far? That would be 2. So the run is to the right 2, and this would simplify to 4. So that's rise over run on that, and I'm going to show it as 4 over 1 for now, because this will help us to figure out what the y-intercept is. So if the rise is 4 and the run is 1, to find the y-intercept we need an x value that's 0, and then we just need to find the corresponding y value. So I'm going to kind of be extending this table upwards like this. So from 3 and 12, using the rise and run that I found on this, I'm going to make it down 4 and to the left 1 though. So from 12, I'm going to go down 4, which would be 8. And from 3, I'm going to go to the left 1, which would be 2. So this takes me a little bit closer to 0. But I'm going to continue this pattern, which is nice because it is linear. So we'll have a constant rate of change. I'm going to go back another 4, or down another 4, which is 4. And then from 2, I'm going to go to the left 1. Minus 1 there. And then finally to get to 0, I'd have to go to the left another 1, which means I'd go down another 4, which would be 0. So that would be the y-intercept right there, 0, 0. Because our x value is 0. So if that's the case, then our equation, y equals the slope times x plus the y-intercept. The slope is 4, and the y-intercept is 0. Now, if you guys wanted to, you could write y equals 4x and just make that a phantom plus 0. That would be fine too. Okay, either one of these would work. One is proportional because it's a straight line with a constant rate of change, and it does go through the origin 0, 0. Now, if we were to graph this, it means it would be a straight line that does go through the origin. But also, we know that it's proportional because all of the y values divided by the x values are the same thing. 48 divided by 12 is 4. 40 divided by 10 is 4, and it would work for the rest of these points on this as well. When that happens, when all the y values divided by the x values are the same, it's automatically proportional. So on this one, it's not proportional because it's not going through the origin, even though it is a straight line, which just makes it linear. Alright, so this graph shows the relationship between the number of months the family has had a DVD player and the amount they still owe. What is the rate of change? What is this one really asking for? But also, that rate of change, that's asking for the slope on this graph right here. So ultimately, we just want the slope of this line, okay? So they've even graphed some points on there for us, which was extremely generous. So we get to choose which 2 points we want to use, but actually those ones may not be as useful. This one is though, because I can see that has a value of 0, 180. And then this point on the other end. Now this won't happen all the time, but it does happen from time to time. Is 12, 0. So at 0 months, they owe $180. And at 12 months, they owe $0. Now just looking at that graph then, before we answer the rate of change, how long did it take them to pay off the DVD installment plan?
1 year.
12 months. Yeah, or a year, right? So after the year or 12 months, they owe $0. So after that, they won't owe anything, which is very nice. But let's find the slope then. So from 180, I'm going to go down and then to the right. And we got to figure out how far down and to the right. So from 180, this is going to go down to 0, so it went down 180. So for rise over run, we have a rise now that's down 180, so that'd be negative 180. And then it goes to the right from 0 to 12, 12. Bam. All right, 180 divided by 12. All right, so this gives us negative 15 then. But this is a word problem, so we need to describe what this means. It means that they are paying off $15 every 1 month. And this would kind of technically be the answer right there. They're paying $15 every month or paying off $15 a month, either way. Graph this equation. Y equals negative 4/3 x minus 3. The common method that we used in class was a table, which you can do, but I'm not. I'm not going to use a table, okay? Because we don't need to. All we need on this is the slope, and we can see that the slope on this one is the coefficient of x, which is negative 4/3. Now what does this tell us? Well, it's rise over run, so actually I'm going to specifically make that 4 the negative. So that means from each point would go down 4, and the 3 is positive, so that means it will go to the right 3. We just need a point to start from on this thing, okay? So, where do we start from? The y-intercept, which is shown in this equation. And that would be at 0, negative 3. So I'm going to start at 0, negative 3. And from there I'm going to use the slope to find the other points. Down 4 to the right 3. So this would be the next point. Now I can't show the next one, but what I do want to show is more points, just so that we can confirm the pattern. So instead of making that negative 4 over positive 3, I'm going to make that positive 4 over negative 3. Now the 4 is positive, so I'm going to go up 4. And the 3 is negative though, so I'm going to go to the left 3. Now look, if you find the tables easier than this method, then use it, okay? But I like this method because it's going to show the stair steps for us. So I'm going to go to the left 3 and up 4 to get this point. And then to the left 3 and up 4 for this point. And left another 3, up 4 for this point. Now it should make that pattern consistent with that stair step. And from here, all we need to do is connect the points, and that would do it. If you were to use the table, you would need choose multiples of 3, because the slope has a denominator of 3. So when I choose values of x, I need some kind of multiples of 3, like -6, -3, 0, and 3. Now the reason why I'm starting at -6, not just because the graph shows that, but I know that if I multiply -4/3 by something bigger than 3, then it's going to be off this specific graph. We'd need something bigger. So from there, we're using the equation to figure out these values. So the equation is y equals -4/3 times the x, which in this case we're saying is -6. And from there, you would need to subtract 3. Well, this is nice because all we want you to do is plug that into a calculator to figure out the y value. But this would be 8 minus 3, 5. So that would be at -6,5, which is this point right here, which we found using the slope instead of the table. So these other ones would work the same way. 1, 0, -3, and -7. Alright, draw a line passing through -2, 5 with the slope of -2/5. So we do need to start with the point -2/5. I'm sorry, -2,5 right here. And then this slope is -2/5. Again, I'm just going to make the 2 the negative and the 5 the positive on this one, just so we can have our directions down precisely. The -2 means that we'll go down 2 from that point, and the 5, since it's positive, means we'll go to the right 5 units. So this point down 2 to the right 5 gives us this point down 2 to the right 5. And again, I could copy that pattern this way if I wanted this point right here. That's all I can fit on this graph. So the last thing I would need on this thing is the actual line. So we should get something like this. Alright, then number 5. Maximus borrowed money from his parents to pay for a game console. Maximus will pay his parents in equal amounts every week until he's paid back the entire amount he borrowed. The table shows the amount of money Maximus still owes his parents at the end of every 3 weeks for the first 9 weeks. Part A, how much does Maximus pay his parents every week? This is the slope on this one. So here's what we know. If he is reducing the amount owed from 420 to 330, that means that he paid off $90, and that took, just like it shows, 3 weeks. So if he's paying off $90 every 3 weeks, then we'll reduce this to 1 week by dividing both the -90 and 3 by 3. So yeah, that'd be $30. We can show the negative if we want. But when we answer the question, we'll just say $30 per week. Part B, write an equation that shows the relationship between the amount Maximus owes and the number of weeks he has paid. Alright, so this will be in the form y, which will represent the amount he still owes, and we know that because the table is always in the xy's. So y is the amount he owes. We'll have the slope multiplied by the x, and then we'll add the starting value to this one. So we can say the slope is the rate of change as well. So Maximus is paying off $30 a week. And how much does he start? How much does he start with? And we can kind of look for 0 on this one in the table, which was shown. So it appears that he owes, to start with, $420. Now again, this could have been ordered pair, which shows the x value 0, which would be more like the y-intercept, but it's the same thing. How many weeks will it take Maximus to pay back his parents? I'm actually going to use the equation for this one. So the amount he owed would need to be 0, and then we're going to solve the equation for x. So 0 equals negative 30x plus 420. And to solve this equation, we would subtract 420 from both sides. So negative 420 equals negative 30x. And then to finish this off, we'll divide negative 30 on both sides. So that gives us x equals 14. So how long would it take him? 14 weeks. Number 6 then, the table shows the cost to rent skates and stuff from Wheelie's Skates and Stuff. Describe the rate of change with words. What is the rate of change and what does it represent? Okay. Well, the rate of change is the slope, so that's all we really need to find on this one. So we'll say that we see that the price increases by $3 for one person. So that looks like it's the rate of change, $3 per person. Because if we write that as rise over run, 3 over 1, it can't really be simplified. So $3 per person. Part B then, write the equation describing the cost plan for Wheelie Skates and Stuff. So again, the table is nice because it sets up as x, y values. So we know that y is the cost, which will depend on the x, which is the number of people. So we got the slope times the x, or the rate of change times x, plus the starting value, or the y-intercept. And we know the slope already is $3 per person. But what's the starting cost for this one? Yeah, this one shows the 100 right there for 0 people. So it didn't say why that $100 is there, some kind of fee or whatever.
Admission.
But yeah, maybe it's admission, something like that.
Well, that's the only thing that
So we'll say plus 100 for the starting value, okay? So the cost, well, I mean, we could say it starts at $100 and then you add $3 for every person. So you just take 3 and multiply it by the number of people you're going to bring to Wheelie Skates and Stuff, and that would tell you the cost. So if you were to change this just a little bit, now this is the general form of the way that I've written it. But if you'd say, well, it's going to start at $100, and then we're going to add $3 for every person. That's the same thing, it's just use the commutative property of addition to change the terms.
you still count that as right.
That's correct, yeah. Because this doesn't change the actual value of the cost. It just changes the way that it looks, but it will still give you the same exact price for every person. So if I wanted to figure it out for 10 people, for example, it'd be $130 whether I use either equation on that. It's a good question. So why does it cost $100 for 0 people? It didn't say, so we get to make a couple assumptions on this one. Yeah, that's good. Some kind of fee or starting cost. Number 7, this one has 4 of them, right? And we did these on the starting problems last time. We got to find the slope of each of these that passes through these 2 points. So we're going to use the formula for this one. So we know it's the y values subtracted from each other, divided by the x values subtracted from each other, because the y values give us rise and the x values give us run. Alright, well the y values on this one are 130 and 190. So I got 130 minus 190, which as a rise gives me negative 60. Then the run is 2 and 6, so that would be 2 minus 6, which is negative 4. So I've got negative 60 divided by negative 4, which would give us a total slope of 15. Same formula for this one, you guys. Okay. So I got my y values, which is -8 and -4. Because it's always set up, each point is always set up x and y, okay? So we know the y values are always the second value in the set of parentheses from that ordered pair. So -8 minus -4, and the x values 11 and 14. Now again, we don't expect you to do this all in your head or even necessarily by hand. We want you to use the calculator to figure these values out. -8 minus -4 would be -4. And 0 minus 14 would be -3. So to simplify this one, the two negatives can cancel each other out, and we got 4 over 3. That would be the slope. For the test, you will not be using decimals, and certainly not mixed numbers. We want to keep the improper fraction because it specifies the rise and run without needing to do any extra calculation. Alright, you guys like the formula way? On the next problem, after this one, I'm going to show you guys a different way though. Then you can choose if you like it well enough to actually try it on these ones, alright? So the y values, again, it's the second value in each of these set of parentheses. So I've got 10 minus -2. And the x values, we got -1 and 5. So 10 minus -2, that would give us 12. And -1 minus 5 would be -6. So the rise is 12, the run is -6. 12 divided by -6 is -2. There it is. I'm going to show this one a little differently. This is what we call the rainbow method, because we like to use rainbows in math because they're so pretty, right? So what I'm going to do is I'm going to connect the y values above and the x values beneath, and that will tell us the rise and run. So I'm just really going from 8 to 5, which means I'd have to go, in the y values, means I'd go down 3. And from 10 to 3 means I would have to go to the left 7 for the run. Now again, this gives us two negatives, which means they cancel each other out, and I've got the slope right there at 3/7. Now the key to this method is knowing that you have to connect the y values above, because that's the rise, and the x values beneath, because that is the run. Number 8, write the equation for this graph. Alright. Well, the equation should be y equals the slope times the x plus the y-intercept. And we will start with the slope, even though the y-intercept can be seen clearly from this picture. So I'm going to choose these 2 points because we have a defined rise and a defined run. See if I choose 2 other points on this line, like this one, and maybe even this one, I can see the rise is up too, but I don't know how far the run is, right? So we're going to go back and use those 2 points. So I can see it goes up, starting here, that'd be 0, 1, 2, and then it goes to the right, to the point, 1. So rise over run, which is the slope, is up 2 to the right 1, which simplifies to 2. So that is our slope. And the y-intercept, again, it can be seen pretty clearly. It's just where the line crosses the y-axis, which would be this point at 0, -1. Again, we don't write that as an ordered pair in the equation. We just write the y value, which is -1. And that is the equation. Alright, number 9. Con and Janet are draining all the water from full aquariums to clean them. The graph shows the amount of water left in the aquarium as Con drains the water. So the graph, we'll just label this is for Con. And the equation, G equals 50 minus 2m, represents the amount of gallons in Janet's aquarium after m minutes. Whose aquarium has more water in it when it is full? Alright, well, we need to figure out how much Con is starting with, which would tell us this point. So at 0 minutes, it looks like he has 45 gallons in his aquarium. Again, that's for 0 minutes. And we should notice that that is the y-intercept, or the starting value. For Janet, she is starting with 50 gallons, because we could write that as G equals negative 2m, which is the slope, but then that'd be a positive 50. So Janet's starting with 50 gallons. So when the two aquariums are full, Janet has 5 more gallons than Con. So Janet's aquarium has more water in it. Well then, whose aquarium is draining the fastest? That's part B. So for Con, we need to figure out the slope on this thing. So we know it's starting here at 45. That's going to go down 5 gallons. But how long does it take? Looks like it's going to take 3 minutes. So Con is draining right now. He's draining 5 gallons every 3 minutes. Whereas Janet, hers is negative 2, which would be draining 2 gallons every 1 minute. Now if we want to compare these straight across, that means that in 3 minutes, Janet would have drained 6 gallons. So, whose aquarium is draining the fastest? It appears that Janet's is as well. So she starts with more water in it, but then hers drains the fastest. Number 10, the following table shows the number of apples purchased related to cost. Fill in the missing boxes in the table, and how much does one apple cost? Well, here's what they tell us is that 12 apples will cost $3. And from here we see that $3 has been cut in half, which gives us $1.50. So if I were to cut the 12 in half, that would tell us how many apples we could purchase for $1.50, which would be 6. So for one, I'm actually going to go back to the 12 for $3. So if I can get 12 apples for $3, then I want to know what the cost would be for 1 apple. So all I would need to do is divide the 12 by 12 to get the 1. So I'm going to take the $3 and divide it by 12, which will tell us how many dollars. 25 cents. Or it's a fourth of a dollar, either way. So if I wanted just 1 apple, I would have the cost of 25 cents, which actually answers part B, right? How much does 1 apple cost? 25 cents. But let's finish the table. So the 48 is 4 sets of the 12. So that means I'd have to have the cost 4 sets of those. So that appears to be $12 there. But what if I wanted 10 apples right here? Well, that would be 10 sets of the 1. So I'd have 10 of the $2.50. So that appears to be $2.50. Well, what about 450? That's 3 sets of the 150. So 3 sets of the 6. That should be 18 apples right there. So we filled in the table and found the cost for 1 apple. Now for this one, we should notice that these values are proportional, right? 48 divided by 12 is the same as 1 divided by 25 cents, or 6 divided by 1.5, and so forth. Number 11, find the slope and y-intercept from each equation. The slopes are all the coefficients of x. So it's just the number that's being multiplied by x, which in this case is negative 2/3. That is the slope. The y-intercept. One mistake we see often on the test is that people just put 8, but I have to take points off for that, okay? Because the y-intercept is an ordered pair. It's 0, 8. We're going to repeat this process pretty much all the way down. The coefficient of x on part B is the slope, 1.3. It doesn't show the y-intercept, but we can show it because it was a phantom plus 0, which means this one is proportional because it goes through the origin, 0, 0. Next one, the slope, is the coefficient of x, which is 7/2. And the y-intercept is that negative 9. But again, that's the y value in this ordered pair with an x value of 0. Again, we should notice that all the x values are 0 for these. So on this next one, we could even just start with 0 something, and we can see it's a minus 9 again, so that'd be a negative 9. But this one isn't showing the the slope, the coefficient of x, so we can show it. It'd be a 1 right there, coefficient of x. And we've seen that when we were solving equations. So 1 is the slope for part D. What is the equation of this line that's graphed? We've already done one, just like this. And we know that the equation needs to be y equals the slope times x plus the y-intercept. So let's start with the slope. I just need to figure out 2 points that I can define, like this one at 0, 5. And I'm going to use this one right here. But you could have used this point as well, or this one. But I'm not using those. So I see that this line goes up and to the right. Well, we've got to figure out how far up it goes, starting from this point up 1, 2, 3, 4, 5, 6. So it goes up 6, and then to the right, starting here, 1, 2. We have a rise of up 6, and the run is to the right 2, and this simplifies to 3, which is the slope. So it is also the coefficient of x. Next up, we need the y-intercept, which is on the graph where the line crosses the y-axis. We already used that point, which was 0, 5. So the y-intercept would be a positive 5 in the equation. And this would be the full equation, y equals 3x plus 5. Write the equation for this one. So this is just a table now, right? The good thing is they gave us the y-intercept at 0, 6. So when we look at the equation, y equals the slope times the x plus the y-intercept, we can fill that in as plus 6 already. Now again, we know that because the x value is 0, so we just look for the y value as the y-intercept in the equation. But we do need the slope on this one. So I'm going to choose the 2 outside points. Why? Because I can. So from 4 to 7, that would go up 3. And from negative 4 to 2, that would go to the right 6. So for rise over run on this one, the rise was up 3, and the run was to the right 6. And this simplifies to 1/2. So the equation is y equals 1/2 x plus 6. Bam. 14. If the points negative 9, y, and negative 8 and negative 9 fall on the line with the slope of negative 5, what is the y value? That's a good question. To figure this one out, I'm going to go back to the formula. So I know that my y value is subtracted and my x value is subtracted. And this one told us what that value should equal. It says it should equal negative 5 over 1. Now, of course, this could be simplified, right? So we could kind of separate this for now and just see what we can get from this, okay? So here's what I can see is my y values are y and negative 9. And I'm going to change that to a plus 9, which may be a little bit more specific and helpful for the 5. And the x values, I've got negative 9 and negative 8. Now this would be a negative 1 when I subtract the negative 8 from the negative 9. Now how does the 1 kind of relate to that 1? Well, it's just opposite, which means that up here in the numerator I need a value of 5. And then these two will have the same value. It's just changing where the negative is, and that's okay. So, to rewrite this, I need y plus 9 to equal positive 5. So what value plus 9 is 5? Well, you could solve the equation on this one. Actually use a different color. And y equals negative 4. So this means that if I were to go back into the equation and replace y with negative 4, then I would get the exact slope, and they have the same values on this one, okay? So that means the y is negative 4 from this y value. There should have been a lot of deep thinking on this one, especially during the practice test, because there will be one like this on the actual test. All right, graph this equation. It's nice because we've already been doing several of these. So for this one, once again, we're going to start with the y-intercept, which would be 0, -3. So 0, -3 would be this point. X value 0, y value is -3. And then the slope shows 5/4. So that means I have a rise over run. And both are positive, so it's up 5 and to the right 4. So from this point, I will go up 5 and to the right 4. That gives me my next point, up 5 to the right 4, and that'd be the next point. Now again, I can continue these stair-step patterns. So I could go to the left 4 and then down 5, which would give me the final point on this one. And that gives me this line. That may not be perfectly straight, but that works. Of course, if you guys wanted to, you could use a table and find all 4 of those if you wanted. But in the table, again, you're choosing x values that are multiples of 4 so that they will fit on the graph, or that they give you whole values, rather. All right, let's graph this one. Once again, we have the y-intercept here at 0, -1, which would be this point. But the slope, it's not showing specifically, but we can show it as a 1. So for rise over run, for this to be 1, we'll just make it 1 over 1. So both of these are positive right here. So from this point, I'll go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and we get all these points from the stair-step pattern. And yeah, we could repeat this to the left as well. Something like this. Then we'll connect the points. That didn't go very well. Let's try again. That's a little better. That'll work. Alright, now we get into the more review section of the review. So these are all questions from previous units, which we love because we should know them and we should remember them as well. So on this one, this is 5 times y to the power of -3, x to the power of 5, times y to the power of -3. Now we need to remember that each of these factors can be split up so that I have kind of 2 different separate factors. And we need this because we want to show this only using positive exponents. So I can't have that exponent of -3. So I'm going to show this as y to the power of -3 over 1 because the negative tells us that we need to reciprocate this term. So that would be 1 over y to the power of 3. Now, of course, we still got that x to the power of 5, right? And we can say that's over 1. And then this would simplify by multiplying these to x to the power of 5 over y to the power of 3, and that is all. I like that idea. So in the fraction for this one, anything with a positive exponent stays in the numerator. So that would be x to the power of 5. The negative exponents will go to the denominator, but it changes it to positive as well.
Kind of like this.
Find the distance between these 2 points, Q and P. All right. Seemed like there was a lot of confusion on this one, but it was from a previous unit. So this one goes beyond simply just connecting the points, which is a good start, actually. Some of you guys even made the right triangle out of this thing, which is important because we need the right triangle. Now, just like we've been doing, we see that this has a rise of 3, and then this would be a run of 4. This is a Pythagorean theorem problem. So, the hypotenuse, which we usually indicate with C, and if we square that, it would equal the 2 legs, 4 and 3. We would square those and add the squares together. So, C squared, again, we don't expect you to do this by hand, but 4 to the power of 2 is 16, 3 to the power of 2 is 9, 16 plus 9 is 25. So, solve this one finally, And for the hypotenuse of this right triangle, square root both sides, and the hypotenuse is 5. Alright, so we got on this one 4, 5, 6, 7 extra angles to find the measure of. And this one is relating, or finding the relation of angles from parallel lines. So they should have said this, even though they didn't. But we get to assume it, otherwise this problem isn't really doable. So F and G are parallel. Okay. So if they are parallel, then that means that corresponding angles, alternate interior angles, and alternate exterior angles are congruent. And vertical angles are always congruent. So that means that angle 2, which is vertical to this 55-degree angle, because it's through the vertex, would also be 55 degrees. That's very good. And that, yeah, that's the next part actually. 55-degree angle corresponds with angle 5, and they are corresponding angles. So that would be 55 degrees. And 7 corresponds with 2 and is vertical with angle 5, and is also alternate exterior with a 55-degree angle. So angle 7 also is 55 degrees. The question, what is the value of these other angles? Well, if we can find the measure of angle 1 or 3, which has a straight angle relationship or supplementary angle relationship with the 55 degrees, then we can find the other ones. Okay? That is correct. Yeah. So yeah, we're going to take the 180, subtract the 55-degree angle, and what do we get out of that? 125 degrees. So angle 1 is 125 degrees, which means its vertical angle, angle 3, is also 125 degrees. And then angle 6, which is corresponding with angle 1, is also the same, 125 degrees. And then finally angle 8, which is alternate exterior, is also the same angle, 125 degrees. So this one may have looked a little difficult to start with, but once we find both angles, the two different angles, we see that they're all just the same. As long as we remember the angle relationships on these, then we can fill this in pretty quickly. Alright, what type of transformation is shown on this graph? And we have gone over 4 different transformations. We've gone over translations, reflections, rotations, and dilations. However, only one of them changes the size, and it is dilations. That's very good. This one has been dilated. And again, that's because we know the size has changed. But it did say to label the image at pre-image. So the image will have the prime marks, like the smaller one does. So this one would be the image. And that means that the original, without the prime marks, would be the pre-image. So this one, the dilation is actually shrinking it, making it smaller. This one requires an actual reflection over the x-axis, which is this line right up in here. So, to reflect this thing, hopefully remember that we got to figure out how far away it is from that reflection line, and then we just reflect it in the other direction in the same distance. So if that's A, this point right here would be A prime. B, which is 4 up from that line of reflection, so we'll go 4 down, and that would be the point B prime. C is 2 up, so C prime should be 2 down from that line of reflection, C prime. So we'll connect these in order to make the actual reflection on this. And there it is, the reflection. Bam. This one's multiple choice. Write your answer in the space provided and evaluate. So I think this was our first unit this year. And when we have values like this with an exponent on the outside, all we're going to do is distribute it to the exponents on the inside. So this exponent would be negative 6 times negative 4, which is positive 24. And then this one would be negative 9 times the negative 4, which would be a positive 36. So we got 3 to the power of 24 7 to the power of 36, these are multiplied. And the only one that reflects that is not this one. This one has the positive 36, but a negative 24, that's no good. This one has positive 24, but the negative 36, no good. So, the answer is C. Also, it was one of these, so it's not none of these. Alright, that completes the linearity practice test review for this unit. Thanks for watching, guys. I hope it helped you guys out.